Lesson we will discuss a proof of this theorem, that is tangent at any point of a circle is perpendicular to the radius. That is the statement of this proof. Okay, that we have to do. Now to go ahead, let us draw a circle first. Suppose this is the circle. Okay, the center of this circle is suppose O, and as the statement of this proof given tells that tangent at any point of this particular circle, let us take the point at this particular circle is here. Okay, so I draw a tangent at that particular point. Okay, this is the tangent at this particular point, and if I this particular point I am doing nomenclature as P, and I am joining that OP line. Here OP is the radius of the circle, that is the radius of this circle, and we have to prove according to the statement of this theorem is OP is perpendicular to this XY tangent. Now, before we going ahead, we know that if I draw random lines from a particular point to that particular line like that, I can draw a lots of many lines. Then the shortest distance will be that perpendicular. That will be the shortest distance for this case. So now, according to this concept, I am trying to prove this theorem, that now I am taking a arbitrary point. Focus on this point, that is a arbitrary point Q I am taking here, and I am joining the center and that Q point. Okay, this line, these two joining line of OQ intersect the circle at a particular point, that is suppose point A. Okay, now here from this diagram we can write that OP is equals to OA. Why? Because the reason is OP and OA are the radius of circle, of a same circle, right? That's why we can write OP is equals to OA. Now here we can write that OQ is equals to OA plus AQ, and this OQ is greater than OA. Let's see that OQ, this is this line, and OA is this distance. So it's obvious that OQ is greater than OA, and we know that OA is equals to OP because both are the radius of a same circle. Then we can write OQ is greater than OP. Okay, now look at here. If I take this point here, then we'll get another line like that. If I take point here, then the line will be like that. So if each and every case we can see that OQ like that, this is OQ dash, OQ double dash, then we can write that OQ dash is greater than OP and OQ Q double dash is also greater than OP. So each and every case OP is the smallest line, smallest distance. So here all this above all discussion we can write that, we can get this conclusion that OP is the shortest distance, right? So if OP is the shortest distance, then according to my previous discussion we can also say that OP is perpendicular to the tangent XY. So hence the statement of this problem, tangent at any point of a circle is perpendicular to the radius, hence proved.